Okay, direct proportion. Now, some people say direct variation rather than proportion. They call it variation. I don't really know what the story is behind it, but they're one and the same. So proportion, variation, whatever name you want to call it, this is basically how it is. Now, direct proportion. If two things are directly proportional to each other, or they vary directly as one another, then if you plot them, you will always get a straight line. So let's look at my little graph and put this into perspective. Let's just say, I don't know, I own a shop and I'm selling bananas. And I've got my bananas there, and you can see that one banana is going to cost you 20 pence. And two bananas are going to, it's going to cost you 40 pence, and so on. Basically, long story short, the less bananas I've got, less money I earn. The more bananas I've got, the more money I can get. Okay, so they're directly proportional to each other. You're going to get a straight line once you get that. And I can now use this to form an equation, but I wouldn't jump straight into it yet. I'm just going to go straight into telling you, first of all, since my number of bananas is directly proportional to the amount of money I get, then I can say that my bananas B is directly proportional to the number of money I get. I called it P in pence, maybe. Okay, so that's directly proportional to how much money I will get. All right, now I've introduced a symbol here, alpha. Let's talk a little bit about alpha. Because they're directly proportional to each other, my alpha can, it actually does take on something else. So wherever you have that alpha, you replace that alpha with equal k, where k is a constant. It's just a number, just a random number. That's what my k is. So even though I said the number of bananas is directly proportional to how much money I make, that proportional symbol of alpha that we use is represented by equal k. So I'm going to do just that. I'm going to replace my alpha with equal k, and now I'm going to get b is equal to k times p. And just like that, I have formed myself an equation which I can now use, well, not yet, so long as I find k, I can now use it to therefore go on to solving problems. Speaking of problems, let's solve a problem. Alright, so here's our first problem for us to have a think about. Let's have a quick read of it, if you can manage to read my handwriting. It's really difficult to write on this. T is directly proportional to M if T is equal to 20 when M is equal to 4. Find all of this other stuff down here. Now, before we even think about solving that, we need to consider what the value of T and M is. So if you can just quickly imagine if we had a quick little graph of this, and we had T down here and M up here. It says that when T is equal to 20, so whatever 20 is, M is going to be 4 at that same time. So we're going to have a straight line that looks like that. And what I want to know is what's the gradient of that line? How quickly is that line going up? And that's what my K is. So let's jump straight into it. So T is 20 when M is 4. So let's start by defining our equation. So T is directly proportional to M. Then now I will replace my proportional symbol with equal K, just like we said before. So T is equal to Km. And now I'm going to use the information they've given me. They've told me that T is 20 when M is 4. So I'm just going to replace this t with 20 and replace that m with 4. So I'm going to get 20 is equal to k times 4. Okay, because m is 4 and km means they're multiplying. Now I'm going to find k. So k is equal to, just a quick little bit of rearrangement, 20 divided by 4. I will divide because they're multiplying here, and obviously dividing would be the way to remove that 4, and that's equal to 5. Now that I know that that's equal to 5, I'm going to write down my main equation now. And I'm going to circle it just to make sure I don't forget it. So my main equation now says that t is equal to 5m. This is my main equation I need to operate from. It means that my k is now 5, and I have substituted it in there. Now, whatever I do for the rest of this question, this is the equation I need to use. So now let's go and start answering part A. Part A says find t when m is 3. So go back to your equation here over here. I'll need to find t when m is equal to 3. And if you're thinking I'm going to replace that m with 3, then you are right. So now, with my working out, what I'm going to get for part A is that t is equal to 5 times 3. All I've done is use this and replace the m with the number 3 like they said I should. And so therefore it means that t is equal to 15. The second part of the question says find m this time when t is equal to 10. So I go back to my equation here. T is 10 and I need to find m. So nice and straightforward, replace t with the number 10. I've got 5 times m, and m is what I'm trying to find. This 5 needs to go, so it needs to divide over there, and therefore I'm going to get 10 divided by 5 is equal to m, which means that, so if I was going to plot this on an equation, my m would be 2 here, while t is going to be 10. Okay, let's bring this down to a close with one last problem. So here again, t is directly proportional to x. If t is 36, when x is 3, find the following. Now before I start finding the following, I need to consider what's going on here. So t is directly proportional to x squared. Sorry, I forgot to mention the fact that x was squared. Okay, and you're going to bump into problems where sometimes it's cubed, it's cube root, or it's square root, or something like that. You just need to put it in just as you've been given it. So in this case, x is squared. All right, so here we go. I need to form my equation straight away. So t is directly proportional to x squared. Replace my alpha symbol with equal k, as we said before. So t is equal to kx squared. All right, so let's get to work. I've been told that t is 36 when x is 3. So I'm going to replace t with 36 and replace this x with the number 3. So 36 is equal to k times 3 square. Because x was squared, when I replace the x with 3, I have to square it. This will now tell me that I'm going to get 36. Why does my 3 look so funny? It keeps going funny. Okay, 36 is equal to 9k, because 3 square is 9, so 9 times k. All right, now I can find what k is. I will carry on my calculations up here. So to get rid of this 9, I need to divide by 9. So 36 divided by 9 is k. So that tells me that k is going to be 4. Now that I know that, I will come back to my original equation here, and I'm now going to make the equation I'm going to use for the duration of the problem. And that means I'm going to get t is equal to 4x squared. This is my main equation now that I'm going to use to solve all the rest of my problems. Okay, that's why I've circled it. Alright, let's get to work. So part A now, find t when x is equal to 5. So here we go. I just need to go back to here, keep t where it is because that's what I'm trying to find, but x is going to be equal to 5. So that is now going to give me that t, sorry, this is question A, t is equal to 4 times 5 squared. So once I replace the x, it was x squared, change it to 5, it has to be 5 squared. I know by BIDMAS or BUDMAS, depending on what you like using, but regardless of what you like using, it means I need to work out the powers first. So this gives me 4 times 25, because 5 squared is 25, which is equal to 100. So my answer is t is equal to 100. Let's look at B now. B says find x this time when t is 400. Alright, nice. I can go back here, replace this t with 400, and I'm just going to hunt down and see what x is. So now we'll have 400 is equal to 4 times x squared, or 4x squared. My first job to do is divide by 4 to get rid of that 4. So 400 divided by 4 is equal to x squared. This gives me 100 equals to x squared. And the last thing I need to do, if I've got a square and I need to get rid of it, what I need to do is square root both sides, and that's going to sort the problem out. So I'll just take the square root, the positive square root of 100. You can't see the 1 in my 100, so I'll just rewrite that. And so that's going to be the positive square root of 100 is equal to x. And we know that the square root of 100 is 10 because 100 is a square number. So x is equal to 10. Alright guys, so that's basically it really for direct proportion or direct variation, depending on what you like calling it. Try doing some problems of your own, and particularly try to aim for the ones where you've got things like x squared or cubes or cube roots or anything like that. They're usually quite good to do. Alright, look out for the next video on inverse proportion or inverse variation.